Today's learning target is that we are going to be able to graph inequalities on a number line. So this first statement is actually an equation because this tells us that x is equal to 2, right? So if I were to graph that on a number line, I would show that x is only 2, no other number, just 2. The next statement, however, is an inequality. So inequalities replaces the equal sign with an inequality sign. So this inequality means greater than or equal to. So if x is greater than or equal to 2, that means that x can be 2, or it could be any number to the right of 2 on a number line. For example, 2.5, 3, 10, 20, so on and so forth. So on a number line, the way we graph that is we put a solid dot on 2 because x could be 2, or it could be any number greater than 2 on the number line. The next inequality says x is less than or equal to 2. So once again, we still see that x could be 2 or less than 2. So x could be 1, x could be 0, x could be any negative number. So on a number line, we're going to put a solid dot on 2 because x could be 2 or any number to the left of 2 on a number line. The next one says x is greater than 2. So x isn't, it couldn't be equal to 2 this time. It's going to be any number greater than 2. For example, 2.1, 2.5, 3, 10, so on and so forth. So notice how this is graphed. We put a circle, an open circle at 2 because x can, it doesn't say or equal to 2, correct? So we start at 2, but we're going to fill in to the right of 2 on a number line to show that x could be any number greater than 2. So similar to the next one, x is less than 2. Once again, we have an open circle at 2 because it doesn't have the or equal to sign. And our arrow points to any number to the left of 2 on a number line. This says x is not equal to 2. That means that x could be any number except for 2. And so that's what that one looks like when it's graphed. X could be any number except for 2. Okay, so another thing I want to point out on the screen is as long as your variable is first, your arrow is going to point in the direction of your inequality sign. So if I made this sign right here an arrow, it would be pointing to the right. And that's how this is pointing to the right. Same is true with this one. If I made this symbol an arrow, it would be pointing to the left. And if you notice, that's exactly how my arrow is pointing to the left. So as long as that variable is written first, your inequality sign and your arrow will be pointing in the same direction. All right, so you guys are going to be solving one-step inequalities. So to solve a one-step inequality with addition and subtraction, you're going to add or subtract to both sides to get x by itself, just like we do when it's an equal sign. For example, if I said that x plus 5 is equal to 10 and I wanted to solve for x, I'm going to do the opposite of plus 5, which is minus 5. And I would get x is equal to 5, right? I'm going to do it the exact same way. The only difference is instead of an equal sign, I'm writing the same inequality. So I'm going to bring down my minus 5 on both sides of the inequality. This is gone. So I have x is greater than or equal to 10 minus 5 is 5. All right, so I'm going to go to 5 on my number line. I'm going to fill in the circle because this says or equal to 5. So I'm going to fill in the circle. And then since my variable is written first, my arrow points in the same direction as my inequality sign. So x could be 5 or 6 or 7 or 8 or 8.5 or 9.1, so on and so forth. Okay, so I have just graphed, if my little dot would stay, I've just graphed and solved the inequality. So you guys try these few, pause the video and see if you can do them on your own. All right, so the first one, we want x by itself. So how do we get rid of +1? We're going to subtract 1 from both sides. So I bring down my x, bring down my inequality sign, and 4 minus 1 is 3. So I'm going to go to 3 on my number line. It's an open circle because it's not or equal to. And I'm going to draw an arrow going to the left, just like my inequality sign. The next one, x minus 3, the opposite of minus 3 is +3. So I'm going to add 3 to both sides. So I bring down my inequality. 4 plus 3 is 7. So I go to 7. I fill in my dot. And then my arrow points to the right. There we go. The next one, my x is over here on the left. I want to get rid of a -2. We haven't done too many of these, but the only way to get rid of a -2 to get to 0 is to add 2. So I'm going to add 2 to both sides. So -2 or -2 plus 2 is 0. So I bring down my x, I bring down my greater than sign, and 6 plus 2 is 8. So I go to 8, I leave my circle open because it doesn't say or equal to, and then my arrow points to the right. And then the last one, x minus 7, the opposite of -7 is +7. So I'm going to add 7 to both sides of the inequality. This is gone. I bring down x is less than or equal to 7. I fill in that circle, and my arrow points to the left. All right. The next slide. Oh, it's a little bit more practice. So you guys try these. I just realized I'm going to get a negative number right here. Oops, didn't mean to do that. So you guys pause the video, try these on your own. All right, number 1, the opposite of +1 is -1. So we're going to have x is greater than 4. Open circle, it points to the right. The next one, how do we get rid of a +6? We want to get down to 0 right here. So the only way to get rid of a +6 is to subtract 6. So this is gone. X is less than 6 minus 6 is 0. So I'm going to put a circle, open circle at 0 and point my arrow to the left. The next one, I'm sorry, I didn't mean to get a negative number, but the opposite of +3 is -3. So this is gone. X is less than or equal to 2 minus 3 is actually -1. -1. So I'm going to fill in that circle, and we're going to point our arrow to the left. And the last one on the slide, the opposite of -4 is +4. So this is gone, and x is greater than or equal to 5. So find 5, fill in the circle, point my arrow to the right, and there's our answer. All right, so if we put, let's say, just to double check these, let's say I'm going to pick a number in my solution set. So let's pick the number 7. Okay, so let's say that x is 7. So if I plug in a 7 right here, 7 minus 4 is greater than or equal to 1. Well, 7 minus 4 is 3. Is 3 greater than or equal to 1? Yes, it is. It's greater than. 5 is in my solution set. So let me say x this time is 5. Well, 5 minus 4 is greater than or equal to 1. 5 minus 4 is 1. Is 1 greater than or equal to 1? Yes, it is. If I try a number outside of my solution set, my answer will be false. For example, let's say I'd pick the number, let's pick 4. If x is 4, 4 minus 4 is greater than or equal to 1. Well, 4 minus 4 is 0. Is 0 greater than or equal to 1? No, it isn't. That's why all these numbers are outside of my solution set. All right, so you can also solve one-step equations, or excuse me, inequalities by either multiplying or dividing. We're going to get to this step later. If you multiply or divide by a negative number, you're going to flip the inequality. We're going to wait till 7th grade to do that because we're not working with negative numbers yet. That will come later in the year. All right, so just as if we had an equal sign, to solve for x, we're going to do the opposite of this operation. Well, this operation says 5 times x. So the opposite of times 5, we're going to divide both sides by 5. So x is equal to 2. I'm going to do the same thing, except instead of writing an equal, I'm going to write greater than. So the opposite of times 5 is divide by 5. 5 divided by 5 is 1, and 1 times x is x. I bring down my inequality symbol, and 10 minus 5 is 2. I'm sorry, 10 divided by 5 is 2. So I come to my graph, I put an open circle at 2, because it's not equal to 2, but it's any number to the right of 2 on a number line. All right, so let's try these. Uh-oh, I just realized number 2, my number line's not going to work. No, yeah, well, just kidding. All right, number 1, x divided by 6. What's the opposite of dividing by 6? I'm going to multiply both sides by 6. 6 divided by 6 is 1, and 1 times x is x, less than 1 times 6 is 6. I find a positive 1 on my number line, and my arrow points to the left. The opposite of times 4, I divide by 4. So x is greater than or equal to 4. Fill in my 4. My arrow goes to the right. The third one, 8 times x. The opposite of times 8 is divided by 8. So this cancels. X is greater than 8. Find an 8, open circle. My arrow points to the right. Number 4, the opposite of divided by 3. I'm going to multiply by 3. So these cancel. X is less than or equal to 6. Find 6, fill in my circle. My arrow points to the left. All right, here's some for you guys to practice. So all of you try these and then come back and check your answers. So the first one, we're dividing both sides by 4. X is greater than 1. Number 2, we're going to multiply both sides by 2. Those cancel. X is less than 6. Open circle, points to the left. Number 3, the opposite of 3 times x. We're going to divide both sides by 3. So x is less than or equal to 4. Fill in the circle, arrow points to the left. Number 4, the opposite of divided by 4. I'm going to multiply both sides by 4. X is greater than or equal to 4. Find 4, fill in my circle. My arrow points to the right. All right, so we're going to write an inequality for each of these statements. It says the greatest value a variable can be is less than 9. The greatest value a variable can be. So this variable right here, the greatest it can be is less than 9. So not 9, it's not equal to 9, but it is anything less than 9. Okay, which means x could be 8.5, right? 8.99999. The greatest value a variable can be is less than 9. It's not equal to 9, so we're not writing the or equal to sign. Okay, I hope that makes sense. So the second one says a retirement community has a sign at its main entrance that says residents over the age of 55 welcome. Write an inequality that best represents the age of residents welcome into the community center. Well, the age, so X is going to represent the age of residents. Can they be 55? Nope. Can they be 54? No. Can they be 56? Yes. So this age must be greater than 55. The age cannot be 55, so it doesn't say or equal to 55, but it can be any number over 55. All right, the last one says there are currently 3 students signed up for a trip. The van can transport only 7 students. Write an inequality and graph it. So if the van can transport 7, that means that the number of students has to be less than or equal to 7, right? So we could put 7 people on the van. We could put 6 or 5 or 4. Well, there's already 3. So we're going to add an unknown number to 3. So this X represents the number of students that can sign up for the trip, plus the 3 that are already coming, and that total must be 7 or less, which is what this says right here. So how many more students? It doesn't say we have to figure out how many more, but, well, actually we do have to figure that out because we have to graph it. So if I subtract 3 from both sides, that means the number of students that can still sign up are 4 or less, because we already have 3 signed up. So I would put a solid dot there. My arrow would go left. Now notice I'm not going into the negative numbers. Why? What does X represent? X represents the number of students that can still sign up. There's no such thing as a negative student. So this is my entire solution set. Okay. All right, you guys, I hope that helped you guys as you're working through these problems this week. I will check in on you guys later. Everybody have a great day. I'll see you later.